My name is Rixin Luo. My topic today is the Ceph messenger situation and optimization. How to enable the unified communication X, short for the UCX in the Ceph, and the result. Here, okay. Here is my agenda. Three major parts. The shortcoming of Ceph current RDMA message module, and what we have done to enable the UCX in the Ceph message module, and finally the performance test. What is the problem or shortcoming of the current RDMA message module? As our testing, we found that the current RDMA message module is a lack of traffic control, leading to a widely performance fluctuate, especially in a large package read-write testing. Second, you can see the right picture. Right? There is a data copy exists in the send and the receiving path. And for the third, the RDMA message module is a limited use. There is a constraint that both the client and the server need to use RDMA to connect each other, but it usually for the client there is no RDMA device. They just use the DSP only. And the next is the log design. I will explain it later. And finally, the RDMA message module use a fixed length to send and receive message. It is a bit inefficiency. For example, if we send a very large package, the package will be split to many pieces, and it will send many times. And in UCX, we can just send once. Oh, I don't know. It's a slide. Okay. This here is the UCX architecture and the key design. You can see the left picture. We have added a UCX stack in the message module. So it is include UCX connected socket for the client side, and the UCX server socket for the server side, and the UCX worker to send and receive messages. We use interrupt and plus the pooling model to handle the device events. And we use while we sending and receive message, we use a different protocol for the different size. Eagle for the small package and the rendables for the large package. Eagle and the rendables protocol is both the UCX features. So UCX has many different types of API to send and receive message, such as the stream message, active message. We just choose the active message to send and receive the message. It is easy to implement zero copy receiving. The active message module, but the active message mode to send and receive package is the package arrives is out of order, so we need to reorder the packages. Here is the running module of Ceph RDMA and the UCX stack. The left one is the RDMA stack. We can see the left picture. There is a RDMA pooling thread and some message worker. And between the RDMA pooling thread and the message worker, it is a shared QPL connections. So it is a required lock. The RDMA pooling the Q pair connection is a map of Q pair to the connection. A Q pair is the queue to send packages to the device and receive the package from the device. The connection is for the message worker use the connection to send and receive the packages. The RDMA pooling thread receives the completion queue event from the device, and we'll find the event belongs to which connection. So the RDMA pooling thread will find the queue pair connections, and the message worker will when the message worker build a new connection, it will insert a queue pair and the connection map items to the shared queue pair connections. This is the lock. And the second, when the RDMA pooling thread receives the event from the completion queue, it uses a system call to notify the message worker to receive the package. For the UCX stack, we can see the right picture. We have optimized the 2-point, the lock and the system call. We just use provide a connection map for each message worker, so there is no lock required anymore. And each message worker builds their connections in their own thread, and the handles the event in their own thread. So if a package is coming, we can just use a thread local flag to indicate the message is coming. So there is no system call. Here is the zero copy message receiving. We have implemented to receive message the equal for small package and the rendezvous for the large package. We can configure the package size to distinguish the small and the big packages. And we pre-allocate the memory while before the package receiving, and we implement the cell copy receiving. For the multi-rail, multi-rail is attractive features on the UCX. So there is 3 types of use multi-rail in the Ceph cluster. First one, it is similar to bound. It can achieve more bandwidth or high reliability. As we mentioned the shortcoming before, the Ceph client can use TCP or RDMA stack to connect the server. There is no limit to the Ceph client. And we can use shell memory to get better performance when deploy the RGW and the OSD on the same host. It is for the performance. This slide, we use the benchmark Ceph perf message to test the UCX stack. We use a 100 gigabit NIC for test with 4 kilobytes package Q depth equals 32. We can see the UCX stack can get a better performance with the same concurrency. And the UCX stack is more efficiency to reach the NIC limit. It just needs 32 concurrency, and the RDMA needs 64 concurrency. For the cluster performance, we have tested. This is the test setting. We just test. We use FRO to test the cluster performance with RBDs with 3 replicas. So we can see the picture, the graph. We can just achieve about 20% performance improvement. For the future plan, we can do more performance optimization, such as the parameter tuning, and try more protocols and the send and receive protocols. That's all. Thank you. Any questions? Okay.
Have you ever compared this with the TCP stack and how far it is away? Because I know from like past experiments that we did that the RDMA stack was not significantly faster than the TCP stack.
Yes. We have just test to compare the TCP. The performance improvement is just about 10%.
Okay, so 10% lower than the RDMA one.
But 10% performance improvement compared to TCP stack.
Thank you.
When you say 10%, you mean throughput, right?
For the test case, the 4 kilo rand write and the rand read.
Does it have any effect on tail latency? Did you measure that?
What?
Does it have a significant effect on latency, particularly tail latency?
Oh, we have not. For the latency we have not to collect the latency, and it is the class performance with very images. The latency maybe is pretty high, both the UCX and the IDMA.
Or actually, hang on. So compared to TCP, the latency is not lower?
Compared to TCP, is maybe is low latency for the UCX, but we do not test the latency.
Okay, that might be an interesting test case. One of the major weak points of TCP tends to be queue non-determinism.
Yes.
To be honest, a 10% improvement over TCP isn't huge
No.
for adding an additional stack. Well, it's a lot of maintenance overhead, right? It's an entire additional messenger stack we'd have to test. So if you could demonstrate a significant improvement in tail latency, that might be a better sale for the upstream community. That said, I mean, the existing RDMA code is clearly not very well maintained, so replacing that with UCX might be a reasonable concept. Not sure.
Yes.
Maybe I can make one comment. I looked at the RDMA code base before, and I think the main issue is that how it is integrated, because it basically, like, it's integrated on a level where it's assumed that it's a streaming API, because obviously the original one it's put on the socket API, right? And that's what you also mentioned, right? They just use send and receive and basically emulate a streaming API on top of a message-based API like RDMA. So you would have to basically remove all these layers to make actual use of RDMA if you want so, right? Instead of kind of emulating a streaming API on top of RDMA. I know, right? And then it goes basically two ways. So it goes from messages to streams back to messages, which is what the current RDMA implementation does. Right. Yes. Yeah.
Okay. Any questions?
So is the idea here to propose a pull request merging this UCX messenger? Is that the idea?
Yes.
Okay.
Maybe we'll create the pull request for in 3 weeks. Okay. Thank you. Sorry for the late.